Welcome to another Tech 90. My name is Jesus Fraga. Join with me today, I have JD. JD, if you want to introduce yourself.
I'm JD. You'll see me here on live videos and broadcasts, doing tech tip videos from our lab in Atlanta, and then also I'm tech support. So when you call into tech support, you may get me as well. We'll work you through the issue.
Perfect. Thanks for that, JD. And I didn't even introduce myself. My name is Jesus Fraga. I'm commercial inside sales. I deal with VRF and multi-pro line. So, if you ever call in for any technical support, I'll answer you. Any sales inquiries, I might get in contact with you as well. But today, if you haven't attended a Tech 90 in the past, here's a rundown of what to expect. First, we'll run a clip from a recent training that covers installation and piping best practices, system modes and component functions. We'll also discuss GREE service tool and benefits. After that, we'll come back and chat with you live and answer any questions up to that point. Then we'll continue with another section of the training to cover simulating indoor and outdoor units that typically pertains to our E6 error codes, H5 and H7 error codes as well. And we'll also explain an FO fault code. That's not necessarily all we're going to cover. We'll cover a plethora of information there to go ahead and benefit you, the contractor, and the technician. And so finally, we'll finish up with another Q&A live session. We encourage you guys to get into the conversation. As a reminder, if you have any questions or comments at any time during the broadcast, use the question mark icon to the right of the screen and send them our way. We'll do our best to answer any relevant questions, and even if we don't have the answers, we can definitely come back and answer those for you. So let's get started. But first, why do we choose a topic to highlight today is multi-zone troubleshooting. JD, if you want to add anything to that.
Yeah, I mean, what we're going to go through is kind of the most common code you're going to see, the most calls that we get in, and kind of dive into those. So, and again, really, we're just going over the most common calls that we see come in.
Perfect. If we want to go ahead and run the video.
What do we do when these machines don't work? And that's what these guys really need to know. So, but I'm a firm believer in you got to install them right too, because if you don't install them right, you're gonna have problems.
That's the key for sure.
So we're gonna start with that. I'm gonna focus your attention to the diagram that I have here to share with everybody, and we're gonna talk about the piping and flow of the refrigerant first. You got to know how the systems are supposed to work. I have a simple piping diagrams that we've had made up. They're very colorful. It makes it easy to follow the flow. I have these for single zone, both single zone and multi-zone. I apologize, on our diagram here it says single zone system diagram in heating mode. That's actually wrong. The diagram itself does say it's cooling mode. It is in cooling mode, so please ignore that for me. Anyway, but I want to talk a little bit about the piping to a mini split and the flow of the refrigerant and what the machine's actually doing with all that. So just following our flow here, you're discharging off your compressor, going to your outdoor coil, releasing our heat, condensing into a liquid, going through a strainer, capillary tube, EEV, strainer, and then we go into our liquid pipe to feed our indoor evaporator, come back as a gas, go through our reversing valve, back in the compressor, in the accumulator, and we start the whole process again. Now, as far as the metering devices go, we need to talk about that a little bit. Some of it, and the way we did these diagrams, we show it with an EEV and a capillary. Some of the machines do have an EEV and a capillary. Some of them will have only a capillary, and some of them will have an EEV only. It depends on the whatever machine you're working on, okay? And how the manufacturer made it, how GREE made it. So, with that said, I also want to talk about these strainers. I can't stress to you guys enough, if for whatever reason, for some reason, if you're putting a torch, whether it be you're brazing on the line set for some reason, you're fixing a leak in the outdoor unit, it doesn't matter. You absolutely need to flow nitrogen through that circuit while you're brazing, because if you don't, the oils that are used, it's not like mineral oil they used in R22. It will scrub the inside of that pipe. All of that oxidation will come loose, and it will end up in them strainers, and you're going to have a restriction. Another piece of advice I have for you is when you're pulling line sets. If you're pulling line sets out to an outdoor unit and you've got to cut the insulation away and pull it off of there because you're going to use a tubing bender, which I highly recommend. Make sure you're putting the cap back on that refrigerant line before you feed that insulation back on there. Trust me when I tell you, we've got pictures where the strainers are all plugged up because they're pulling the insulation off of it and they drag the insulation right into the pipe. Or if the line set's laying on the ground and you get it stuck in the mud and you get a little bit of dirt up in there, it don't take much and you're going to end up with plugged up strainers. So you just taking a little time to be careful what we're doing and making sure you're covering the pipes up when you're installing them. So I want to talk a little bit more about your line sets with mini splits. So you got your liquid pipe and your gas pipe. A lot of people want to call that the suction liquid line. Well, essentially, yes, it is the suction line if it's in cooling mode. But if it's in heating mode, it is the discharge line. Daniel has talked about it before. When we're down here, I'm going to talk about it again. The best way to look at this is that is an extension to the indoor coil. So if that indoor coil is in heating mode, these two pipes are an extension to that coil. If that indoor coil is in heating or cooling mode, those two pipes are an extension to the indoor coil because your metering device is in the outdoor unit. So now the other thing we need to take into account here, the way these mini splits work, is you've got that discharge temperature sensor right off the compressor. That is a 50K ohm resistor. That's one thing I really like about GREE. GREE is consistent in that they use a 50K thermistor for discharge pipe. They use 20K thermistors for coil, whether it be on the indoor coil or the outdoor coil. Those will be 20K thermistors. If it is measuring air temperature, whether it's inside or outside, those are going to be 15K thermistors. So that's the easy way to remember it. If it's measuring air temperature, it's 15K. If it's measuring pipe temperature, it's 20K, with one exception to that rule. If that thermistor is on the discharge line of that compressor, it is going to be a 50K thermistor. Why? The reason why is because that is the hottest pipe in the entire machine. A 20K thermistor is not going to work in that application. That's why they're using a 50K thermistor. So, moving on. You go into heating mode. So we got two of them in heating mode. That's awesome. So this one we actually named right. Anyway, so discharge off the compressor, going through a reversing valve. It's now switched. We're going to the hot gas inside, releasing the heat to the indoor unit, and we are feeding our liquid back, going through our metering devices, feeding our refrigerant in our outdoor unit, absorbing heat from outside, boiling that gas off. Our suction gas is coming back, going into our compressor. So keep in mind, that's how this machine works. In other words, what I'm getting at is you have that coil thermistor on the indoor unit, you have a coil thermistor on the outdoor coil, you have an indoor ambient thermistor, you have an outdoor ambient thermistor, and you also have the discharge thermistor. So the program in that board in that outdoor unit is looking at all that data. It's saying, okay, let me give you an example. Let's say I've got the indoor unit set to 75 degrees in heating mode. The indoor ambient is 65 degrees. I have a 10-degree demand for increasing the room temperature in that room. So that's going to equate, that gets interpreted and sent back to the main board in the outdoor unit. The outdoor unit saying, hey, okay, I got a 10-degree demand that I've got to try and get the temperature up in that space. So then what it also does is that's going to help adjust the speed of the compressor. By controlling that hertz speed of that compressor, and we ramp that up more, it's watching this coil temperature in here. So if you have the fan on auto, now if you put the fan on a selected speed, low, medium, high, then that's the speed the fan's going to run on. But if we put it on auto, that fan speed is going to adjust according to the temperature of that coil. And that's why we recommend all the time auto mode, because the fan speed will be according to that coil temperature. Same with what's going on out here. It's looking at your outdoor coil temperature. Even in heating mode, it's looking at that outdoor coil temperature. It knows it's got a 10-degree demand in here. It's going to try to absorb as much heat as it possibly can. So it's going to dial the fan speed up outside to put as much load on that evaporator as possible to try to gain as much heat as possible and then transfer that heat to the indoor coil. So it's all working together. Meanwhile, the machine is also protecting itself. It's looking at the discharge temperature of that compressor and making sure the compressor is not getting too hot. If it does, what's going to happen? That compressor speed is going to slow down, which inadvertently is probably going to slow down the outdoor fan speed and the indoor fan speed because we're running in what I like to call a limp mode. Instead of just, excuse me, instead of just shutting down altogether, it's trying to survive, right?
Right.
All right, so now let's take it one step further. So now we're going into a multi-zone system. So let me go back a minute. What I was taught when I first started into HVAC is a basic refrigeration system. That's all this is. JD, I'm sure you've gotten the phone calls too, and I've gotten the phone calls where the guys tell me on the phone, man, I really just don't know much about these mini splits.
Yep, all the time.
Yes, you do.
Yeah.
If you understand the basic refrigeration circuit, you understand how a mini split works. You just got to force yourself to think about it. That's the point I'm trying to make. Because any basic refrigeration circuit is going to have a compressor, it is going to have an indoor coil, it is going to have an outdoor coil, and it's going to have a metering device. Those are your 4 major components that you have to have. All we do in mini split technology is build on that. So, and especially all we do is heat pumps. We don't even sell cooling only models. They make them, we don't sell them. The only difference there is we're adding in that reversing valve so we can have flow in both directions and we can actually provide heating mode or cooling mode, okay? So with that said, you've got your basic components here. Now what they're doing is they're building on that by throwing these thermistors and everything in there and monitoring the operation of the unit and controlling the speed of the compressor and the fan motors to try to satisfy the load more quickly or more slowly, depending on what it's trying to do. And I say that specifically, I said more slowly. Mini splits will do everything they can do to not shut off. The whole energy efficiency savings comes from that machine running at a very low rev and maintaining the temperature in the house. That's where you get your efficiency from. So the whole idea is to let that, set it and forget it. Let the machine do its thing. So for you guys out there troubleshooting these things, and JD, you've taken the phone calls too.
Oh yeah.
Every time you pick up that remote and you make a change to it, you're making the whole system have to rethink.
It has to relearn.
It's got to relearn. So you've got to give that machine time to relearn what you just told it to do. Even though all you did was make a temperature change on the indoor unit, it's not going to be immediate. It's the whole board out there is going, oh, wait a minute. We just increased our demand from a 10 degree demand to a 15 degree demand. It's going, whoa, man, okay. Now what do I do with that? Or if you're trying to look at it, it's like, hey, this thing seems like it keeps overshooting temperature. Now all of a sudden you're giving it just a 1 degree demand when it had a 5 degree demand before that. This machine's going out there going, what are you doing to me?
Right.
Right?
I get that call often. Yeah.
It's what it's doing. You got to give the remote time and the indoor ambient sensor time and the outdoor board time to think about what it's doing. The one thing I can tell you about GREE equipment is it will teach you is a whole lot of patience. Because nothing happens fast, you know. We want to get in, we want to troubleshoot that unit, and we want to get out. But you can't always win that war. You've got to give these machines time to think. But once you understand that and you move forward with that, it's not as difficult as it sounds. So now let's get into multi-zone. Again, I said if you guys understand the basic refrigeration circuit, which is what a single zone system is, you can understand a multi-zone. Because all we're really doing here is the same thing, but only we're adding a metering device for each indoor coil. We still only have one condenser coil, but we've added a metering device, and all we did was parallel our indoor coils to that one outdoor unit. But in order to do that, we've got to control flow into each one of those, and that's why you see these added thermistors. You're going to have a gas and a liquid thermistor for each circuit. So you got a liquid and a gas. Because if this coil or that indoor unit is calling, excuse me, if that indoor unit is calling, it's got to be able to monitor that refrigerant flow going through that indoor coil, because that's only one. If I've got this one calling and that one calling, I got to be able to share my refrigerant flow to both of these coils going in, and then thirdly, this one. So let me put this in the real world troubleshooting for you. What if this machine is low on refrigerant? If I've got all three running, and let's say I'm running in cooling mode, and we talk about this all the time, don't we, JD? 20 to 25 degree TD, right?
Yep.
So our air entering and our air leaving, if we're about a 4 degree demand, in other words, let's say it's 75 degrees in the house and we set it at 70, 71 degrees, we got a 4 to 5 degree temperature demand, right?
Right.
So once you got that 4 to 5 degree temperature demand and you leave the machine run for a little bit, you should get, if you measure your return air temperature going into that indoor wall mount and out of that wall mount or ducted unit or whatever else you're working on, you should have a 20 to 25 degree temperature difference across it. So let's say I run this machine, but it's low on refrigerant, okay? Which is also going to do what? It's going to increase this discharge temperature. Because if I feed in refrigerant to all of these indoor coils, and now I've got to get that cool refrigerant gas coming back to my compressor to keep it cool. Well, if I don't have enough refrigerant, what's happening here? I'm starving my return refrigerant gas coming back to that compressor. So if my gas coming back to the compressor is warmer, what happens to my discharge temperature?
It gets hotter.
It gets hotter, right?
Yep.
No different than a restriction or anything else. So what you're going to see when you have a system that's low on refrigerant, you're going to see elevated temperature, discharge temperature. Now, if you have the service tool, which we're going to talk about very shortly, you can see that discharge temperature, and you would see that that temperature is quite elevated. But let's say you don't. You don't have to have the tool. Let's say if I run this unit, and I've got enough refrigerant in it that I can satisfy one, but I can't satisfy all three. So in other words, if I go across and I got all three, and I got, let's say, 15 degree TD, a 10 degree TD, and maybe a 12 degree TD, but then I shut off circuit B and C and only leave A on, and all of a sudden that jumps up to a 20 degree TD. You just answered your own question right there. The thing's low on refrigerant. I had enough refrigerant to satisfy one indoor. I don't have enough refrigerant to satisfy all three. So the data that you recorded just by doing a simple temperature drop answers your question whether or not you're low on charge. It's a simple diagnostic procedure. You can also do it with the service tool, which we'll talk about. So, I mean, could you have one of these circuits not being right? Yes. There's another thing. So you got a liquid thermistor and a gas thermistor for each circuit. So if one of these thermistors is out of range, it's also going to cause a flow problem into that coil. So you could have a fully charged system. This circuit work fine, C work fine, B work fine, A works terrible. And it could simply be that you have one or more of those thermistors out of range. So that's why when we preach all day long to you guys, when you call in, look, you've got to unplug those thermistors. They're marked on the wiring diagram of the unit, and take an ohm reading to those thermistors. And what I preach all the time, JD, you can maybe you got a different thought process to it, but I tell them, look, leave the thing off for 30 minutes.
Yep.
Look for the odd man out. Even if you don't have a chart, if I'm checking all of the thermistors that are strictly going, that are my liquid and my gas thermistors, and I ohm this one out, and let's say it's 20K ohms, and let's say I ohm this one, and it's 20K ohms, and this one all of a sudden it's 5.
And you know you have a bad one.
I just found the bad one, right? Because the thing ain't been running for 30 minutes. That means all those temperature sensors are reading the same outdoor temperature because they're sitting there stagnant.
Right.
Right? Same with the liquid. Run down those. If I got 20, 20, and all of a sudden 5, I've just found the bad thermistor. So I know I need to change that thermistor on that circuit or change all of them. I don't really care. But you know you got one bad one, and that's why that circuit's not working. I've also had calls where one of these thermistors was so far out of range, not enough that it actually showed it electrically open or shorted, but the machine couldn't read that resistance properly. It never gave me an error code. All it did was made that circuit not come on. B and C work fine. A won't turn on, no matter what I do. Ohm out those thermistors, find one way out of range, change that thermistor, now the machine works. So it could be something that simple. So basically heating mode is the same thing. I'm not going to sit here and go through the flow for the whole thing. I think you guys are getting my whole point of what I'm trying to talk about here. So we've got a single zone mini split here. We've got our service tool. So some things to talk about with the single zone service tool. And this is what we're going to demonstrate. The single zone service tool can be used as a data logger. In other words, not really a data logger, but to real-time see data while the machine is running. Okay? Basically what I'm telling you guys is this tool is your eyes and your ears into the system. The other thing that I was always taught when I first got into trade school and I was going through trade school, we were learning about doing temperatures to refrigerant lines. Why do we take the temperatures of the refrigerant lines? Back then, guys, they didn't have temperature clamps that you just clamped on the refrigerant line.
No S-mans?
Easy peasy, you know what I mean? You had to strap on a thermometer, or you took a piece of metal tape and you taped the thermocouple to it. Which is the same thing, if you think about it realistically, that GREE is doing with those thermistors. They are putting thermistors on the copper pipe, and that is your eyes and ears into the system. Subcooling. Everybody loves to talk about subcooling. Well, and they want to know, and come on, you've had this question how many times, what should the subcooling be on that mini split unit? So I'm going to answer that question. We don't know. Because they're variable speed machines. You can't lock it into a speed. You don't have a TXV. TXVs are great metering devices. Nothing against them. Are they as precise as an EEV? No.
No way.
Never. The thermistors, GREE's already got them on there for you. They give you the eyes and ears into the system. You just need the service tool that's going to read that for you. This service tool will give you, as we talked about just a minute ago, that I was showing on the piping diagrams, you have a temperature thermistor on the condenser coil, right? Well, if I take that condensing temperature and convert it to pressure on a pressure temperature chart, then I know the head pressure, don't I? They give you a thermistor on the indoor coil. It's on the middle of that evaporator coil. So if I know the indoor coil temperature and I use a pressure temperature chart, I also know what my suction pressure is. Right?
Yep.
Discharge temperature sensor. We talked about that. If we're starved of refrigerant, our discharge temperature is going to be too high. If we're overcharged, our discharge temperature is going to be too low. That's superheat. It's total low side superheat, including heated compression, right?
Yep.
So if it's total low side heat including heated compression, this gives you the discharge temperature. So if you start learning what normal discharge temperature should be in a loaded condition, you'll know when it's too hot and you'll know when it's too cold. But you know what also is going to know? This machine. It's going to tell you, hey, no, you can't do that. How do I know? That's a rheostat. JD and I were playing. We hooked it up. We set this thing to specifically 50K, which is a 50K thermistor. We said the discharge thermistor is 50K, right?
Yep.
What did we end up with when we ran it for a little while?
An E1 or an E4?
It was E4.
E4, yeah.
Because of discharge temperature.
Yep.
But the discharge temperature couldn't have been out of line because it was at 50K.
Right. Because it was looking for it to increase and it didn't
There
increase.
you go. You can't lie to this machine. It's going, wait a minute. No. With the way the compressor speed is, with all the stuff this thing is doing, that discharge temperature ain't moving. There's something wrong here. So you can't cheat it. My point to all this, guys, is look, we have service tools. I encourage you to buy the service tool. But what's the other big complaint we always get with hooking up gauges to the unit?
I mean, you lose refrigerant, and it's a critical charge.
What else?
I'm not sure.
Especially heating mode.
Oh, the pressure's so high.
Well, what else? What do you always hook up when you hook up on a unitary product? You have two hoses, right?
Correct. They hook up their low side and ruin their gauge.
No, they can't hook up both sides.
Oh, yeah.
Right?
Yeah.
That's one of the biggest complaints we get with mini splits.
Right.
You can't get both sides of the system. I get it.
Well, I have a lot of...
I'm used to being able to see both sides of the system too. I truly am. That tool is going to give you both sides of the systems, both heating and cooling.
Yep.
Because it gives you all the information you need to know. Because if I've got my outdoor coil temperature in heating mode, and I convert that to on a pressure temperature chart, I know what my suction pressure is, right?
Yep.
If I take my indoor coil temperature, which is now my condenser, and I convert that back to pressure on a pressure temperature chart, I know what my head pressure is.
Yep.
So I don't really have to have gauges hooked up to be able to get both head pressure and suction pressure with a service tool. That's my point.
Saves
Okay?
a lot of time.
Saves you a lot of time. The other thing this thing will save you a lot of time on, so it's a data monitor, and there's a whole lot more information that you can get off this service tool we're going to talk about as well. And we got this thing bugged, we got this thermistor on it, we're going to play around with it, let you guys see it, what we're talking about. But also the service tool has another great use. What is that?
We can either act as the outdoor and control the indoor, or act as the indoor and control the outdoor.
In other words, we can simulate.
Yes.
So one of the biggest phone calls we get into tech support is about E6 troubleshooting, which is a communication fault between the indoor unit and the outdoor unit. They can't talk. And when it can't talk, it don't run. That's the biggest one. The error code troubleshooting we have does a really good job with all the voltage readings and stuff, but I'm here to tell you it does not replace this tool. This tool is so much easier to do an E6 troubleshooting. And we'll demonstrate it for you. What JD was saying is, I can hook this service tool up, and I can disconnect the indoor unit communication wire. I can hook up to the outdoor unit, and I can simulate an indoor unit, and this machine will come on and run. I can hook up from the wires out here, disconnect my 2-wire going inside, hook up the service tool to the 2-wire going inside, and I can simulate the outdoor unit and make that machine run, provided the wire between them is good. If it's not, then I can go right to that head and hook it up there and see if I can simulate the outdoor unit and make the head run. If I can, then I know there's a problem with that cable between the two.
Yep.
It's a fail-safe way. I'm telling you, it works, and we're going to prove it to you and show it to you in just a minute here. But we got it set up as data monitoring first, because we already have it set up with this discharge thermistor in here that we're going to play around with. So we'll start with that.
Welcome back, everyone. I think that was a ton of information. You know, one of the most important things when we're talking about, you know, system that you're working on is definitely the location and exactly what's inside the unit. You know, I get a lot of questions like, where's the expansion valve on this unit? So especially on multi-zone, you know, a lot of people figure that they're at the indoor head, and that's not the case as we've seen on the video. Uh, what are the main things that you get asked, JD? You know, I know you take a lot of technical calls on the multi-zone and mini split side of it. So
Yeah, we get a lot of calls on, location of the EEV. A lot of people think that's on the indoor unit. That is why we have the 10-foot minimum on the line sets, is because the EEVs are on the outdoor unit and it uses that first 10 foot of piping to meter the refrigerant. So it is crucial to have that 10 foot. So, keep that in mind. And also, people that, have the outdoor unit really close to the indoor, and only run a 5-foot line set. I had a contractor call in the other day. He had two heads. One head, he's just not getting a good delta T. He had like a 15-degree delta. Ever since he installed it, he tried tons of different things, adding refrigerant, removing it, replaced sensors, EEV, and it ended up being a 5-foot line set. And he added the other 5 foot. Just be sure if you do, need to add piping for a scenario like that where your outdoor unit's really close, to put, if you do put a loop in there, be sure to have that loop going horizontal, not vertical, because that'll create oil traps. But the contractor extended the line to 10 foot, and he ended up having like a 25-degree delta. So it fixed his issue, because it needed that 10 foot of piping to meter.
right. So I noticed on the video that we had just shown there, it's pretty much we're explaining the sensor locations, right? So we have an inlet and outlet temperature sensor at the UV coil, or at the indoor coil, and we also have, a very critical sensor on the discharge pipe, which I know because I see it in our technical in our queue. A lot of people call in, and it's the FO code, I believe, right, JD? That's
Say
whenever
that again.
an FO code as far as low on refrigerant.
Yeah,
Yep.
yeah. An FO fault code would typically be generated by the indoor coil sensor. And like I
Okay.
tell people, when they call in, if you have an FO code, 95% of the time it's going to be low on refrigerant. If not, if it doesn't do, you do a hard reset of 10 minutes, power cycle, turn power back on. If it doesn't reset, then your sensor is probably bad or open. Your sensor could be out of range, but I'd say 95% of the time, if you get an FO code, it's low, I would go look at your flares and just, again, make sure you use a torque wrench and a good flaring tool, good flaring gauge, a flare gauge, so that way you get the proper flare on there.
Right. Right.
Um,
So looks like we have a question coming in. They're asking about a multi-zone, it looks like, a scenario. So he's asking, uh, so I have a 3-zone unit, right? And so I've turned on one. So let's see. I turn on one zone, right? And he said that it's running low pressure, but whenever I turn on a second zone, he said for some reason the pressure seemed to be normal. So I think right off the bat, I kind of know what that is. It sounds like it's either cross piped or cross wired.
that that was my first thought too. Yes,
Yeah.
especially if it's cross pipes or wired. The best way to check the system, I mean, ideally, if you can put it in cooling mode, you can do it in heat mode. But if you put it in cooling mode, turn both the heads to cooling, one head all the way up to 86, another head all the way down to 61. And, the one that's turned down to 61 should start cooling. If the other one starts blowing cold air, then we know we have those two cross pipes. But that's
Right.
the fastest, simplest way to check it, because a lot of them are in high line and you can't see the wires and track them to make sure they're not crossed. So the easiest way would be then just to, turn them both on, one all the way up, one all the way down, and see which one starts cooling.
So right, and it's good to mention, in multi-zone. So, it's really easy to do that. When you're talking about running multiple line sets, especially if you're going through a chase, through the side of wall penetration, it's really easy to go ahead and run all your line sets and get them jumbled up and jumbled mess. And so it's not like it's impossible to do. I
Right.
know I've heard, so there's just no way that I cross pipe this. There's just no way. And 9 times out of 10, that's the case, especially if that's what we're getting back as far as our diagnostic information.
Yeah. A lot of times you'll have a couple people on the job. If you have a helper, you have one person inside pulling the wire, one person outside. That's a lot of times how they get crossed up too. You're just not doing it all yourself. You have a helper. So
Right.
that's why it's always good just to mark and label your wires, your refrigerant lines when you're doing your install. Tape them together, label them so that way you don't get them crossed up. Sometimes you have to leave and come back. A couple days later, you might forget what you're doing. So that's why it's always good just to tape them all together, label them so that way you don't get them mixed up.
Exactly. I did want to mention, we kind of covered it in the video there, you and Greg did, uh, but pretty much, so I know we're talking about a mini split, but as far as refrigeration and the cycle of it, nothing changes. I'm pretty sure you've heard it from the technician and contractors out in the field. They have an error code and it's like they just halt, they stop. You call them and they're like they haven't gotten pressures, temperatures, nothing like that because they're just relying on that error code and just be like, you know what, all my refrigeration experience is out the window. And it's like nothing changes. We're still trying to move heat or cold from the indoors back to wherever it's not needed, right? So it's still a refrigeration cycle. It's just
Yep,
the EEVs are obviously going to be in a different location when we're talking about mini splits, and we're going to have a couple different boards, but I mean everything pretty much stays the same as far as refrigeration goes.
exactly.
Yep. And so we have any more questions come in, JD?
Looks like there was one question that came in. Someone asked, is there any plans to have a service tool for the Flex?
Oh, okay.
Um, so yes, there is plans in the works. It is being I know it's going to come out soon. I don't know if we have an actual date yet, but there is a plan to come out with one here shortly that will plug into the board on the Flex unit and give you all the same information that we're going to go over on the next clip about the service tools. So good question.
So it would be good for our viewers to tune into our previous broadcast, as I believe James and Greg had went over some of that information. Is that
Yep.
correct? Yep, that's right. And so if we see here on our shared screen, we have the Multizone uh, service tools here for you for your reference in case you're ever looking for them. We also have the Multi-Pro uh, commissioning and control tool, which gives you a lot of vital information and help out your technicians in the field, troubleshoot and cut down the time that it takes for them to troubleshoot it because it literally gives you all the parameters. I mean, everything that you look for: EV steps, compressor hertz. It even gives you bus bar voltage, so uh, it's just there for your reference.
Oh yeah. There's a lot of good information. I mean, if you're installing GREE or even just servicing them, I mean, it's going to save you a ton of time to have one of these service tools.
Right.
Just to plug in, it gives you all your sensors, like the EEV step, and gives you almost everything you need to know about the unit in seconds compared to tearing into the unit, trying to ohm the sensors to see if they're in range. Just you plug it in, it's going to tell you all your sensors right away, and tell you what mode you're in, tell you what fan speed you're on in the indoor. It basically tells you how the whole system's operating.
Right. So it looks like we
Um,
have another question coming in here. It looks like it's coming from Evan. He was asking about the service tool there. It looks like he's wanting to know, can I use a multi-zone service tool on a single zone system?
yeah, good question. So, um, the single zone can be used on the multi-zone. So if you're going to get one tool, I'd recommend getting the single zone. You can plug it into the multi-zone, but you have to plug it into each individual head to get the information. The multi-zone can only be used on the multi-zone. It actually plugs into the board to where the single zone does not have that plug. To where multi-zone, you plug it into the board, it's going to tell you the whole system. You can, bring the system on, check, it'll tell you, all the information we're getting ready to go over here in this next clip. But again, if you're going to just purchase one, we'd advise getting the single zone because it works on single or multi.
So again, guys, we want to remind you, go ahead and join the conversation to the question mic icon. Go ahead and ask any relevant questions, and we will do our best to go ahead and answer those for you. And even if we don't have the answers, I'm pretty sure we can find the answers, and we'll come back to you at a later date with what that answer would be. So if we want to
Oh
run the
yeah.
next video, we can do that.
So let me get this thing powered up. You want to go ahead and turn it on?
Yep. So with data monitoring, we have both the indoor and outdoor unit hooked up and we're spliced into it.
Okay. So we got it running heat mode because believe it or not, we're standing out in this warehouse and it's kind of chilly out here. So I've been kind of freezing. So first of all, Daniel made the mention to me to tell you guys, hey, wire nuts aren't not cool with the 14.4 wire. We're only doing this for convenience to be able to show you, because we got to switch wires around real quick, and to speed up what we're doing in this training. We didn't want to have it, we didn't want you guys to have to wait, because trying to get the wires switched underneath them screws and stuff just takes a lot more time. So if I can get Nick, hopefully he can zero in over my camera here and zero in on this. All right, so it's giving me my compressor frequency, expansion valve step, which is 225. That's fine. All right, so discharge temp, 25 degrees Celsius. That's right at 77 degrees Fahrenheit is what we had it set for, and this is where we got the code.
Yep.
So what I want you to do is I want you to turn that dial to the right just a little bit, and we should see our discharge temperature go up. Yep, now we're at 30 degrees Celsius. Daniel, can you help me out and tell me what 30 degrees Celsius on the 50K is?
86 degrees.
86 degrees. Okay. So let's take that up a little bit more. The unfortunate thing, guys, so we're at 42 degrees Celsius now.
108.
All right, so we're going to stop right there for just a minute. So the unfortunate thing to the service tool is it is all in Celsius. There's no way around it, okay? So having a copy of the ohm chart makes it real easy, because we give you Fahrenheit and Celsius on that ohm chart. So if you're using the service tool and you have a copy of that, it makes it real easy. You don't have to use a phone app or anything like that, converting it back and forth. So
You can even print it out and just put it with your tool.
discharge temperature now is at 43 degrees Celsius. All right, so let's take that up a little bit more. (63 degrees Celsius).
148.
So we're getting pretty hot. I think the 148 discharge temperature, in my experience, guys, because I've dealt with this a lot, that's not an ungodly discharge temperature, okay? I don't know if the machine would fault out on that or not. But when you start getting at like 175 plus, that's an awful hot discharge. So when I say, in part of my experience with that, is remember when we were just talking a few minutes ago, I was talking about the multi-zone unit, and if you've got high discharge temperature, it's a good indication you're low on charge. Well, in my experience, I've dealt with machines where they were low on charge, and I'd run one indoor unit, my discharge temperature was pretty decent. And then all of a sudden I'd turn on the second unit, and my discharge temperature would go up even more. Then I'd turn on the third unit, my discharge temperature. So the only thing I was doing was putting more demand on it. The unit was low on charge, which was causing my discharge temperature to go up. So then you take that same machine, the leak gets repaired or whatever, you evacuate it, you weigh the charge back into it. Now you sit there and monitor that discharge temperature, and as you're bringing on those indoor units, that discharge temperature don't sit there and keep creeping up like that. And you start getting into a more normal zone. I can't just blatantly tell you, hey, this is the discharge temperature you should be running at, because your load conditions change all that, right? But 150 degrees, in my experience, is not an excessively hot discharge temperature, okay? But when I start getting 175 plus, now I'm starting to get concerned. So we're gonna go ahead and increase it some more. So right now we're at 63 degrees Celsius.
That's maxed out.
And we're, well, not that much, back it off.
Oh,
Back it off. It might be too late.
it coded out.
Man, it did it quick. So it just went out on high discharge temperature. And if we wait long enough, the display on the unit should actually give us the fault as well.
I'm gonna wheel it back.
No, leave it up.
Okay.
I want to let it go ahead and fault out at this point. It says air high discharge temperature protection for compressor. And I'm going to make sure he can kind of zero in on that. All right, I'm going to wait a minute. I'm hoping that the unit's going to actually display it. So you can get off of that for a minute, Nick. I'm hoping the unit's going to actually show our E4. So we'll give it just a minute. Then we started out like this, guys, so that we can demonstrate, you know, shoving it into a high discharge temp code. So obviously we're not going to come out here and let refrigerant out to cause that to do it. So we put a rheostat on it just so we can play around with the discharge temperature and actually show what happens when you get the discharge temperature too high. So we're trying to simulate air codes as best we can for the conditions that we have to be able to show you guys. So with that said, we set it up like this so that we can show you that real quick. Then we're going to power the machine down and we're going to demonstrate simulating the indoor unit and demonstrate simulating the outdoor unit so that you guys can see how well this tool works for E6 communication troubleshooting. But I wanted to wait a minute and see if this thing will actually, you know what, now that I think about it, JD, I don't think it will. I think unless the temperature stays up that high, which I can't imagine it would.
Right.
Normal situation, it wouldn't. Okay, and
Yeah.
we're playing with this thing. So what I'm saying is it's not one strike you're out on these machines. So we may be waiting for something there's no point in waiting for. So I'm going to go ahead and kill the power to it. But so it probably has to have at least 2 or 3 high discharge temperatures before it's actually going to fault out and say, you know what, we tried to slow the thing down. The machine's thinking, we tried, limiting the frequency of the compressor. We tried this, we tried that, and finally, we've done this, 3 times. A service technician needs to look at it. The machine don't actually tell you that, but that's what it's looking at.
It attempts to continue running regardless.
These machines will do a great job of protecting themselves, and the machines do a good job of trying to stay online to give them some heat or some air conditioning without actually faulting out.
Blacking out just permanently.
Right.
Yeah.
And that's where I say the service tool actually is very beneficial to you guys as well, in that, let's say you're just going out and doing the preventative maintenance for them. You don't have to hook a gauge up to it. You can hook this tool up, and all you do is sister the wires. It's 1, 2, and 3. So you took the tool, I got wire nuts on there just because I told you I had to switch the wires around.
They are color-coded and numbered.
But all you got to do is hook them up 1, 2, and 3 with your wires also. You got your 1, 2, 3 wires going to your indoor unit. All you do is double up on those, 1, 2, 3, and then you're able to just turn the machine on, turn the service tool on, and you'll select data monitoring, and the machine will just run, and that data monitor could be on there for years if you left it there. All it's doing is monitoring the operation of the unit. But we can also do the simulation. So let's do the simulation. We'll start with, let's simulate the indoor. All right, here we go, guys. We're going to get rolling here now. So we're going to simulate. I've disconnected the number 2 wire going to the indoor unit and only hooked up the service tool to the 2 wire to the outdoor unit. The tool comes up, and it says on here, I want to make sure Nick's zeroed into it. It says data monitor, and then we can go to next. Now it says replace indoor unit to detect outdoor unit. That's what we want, so we're going to hit OK. So now, this indoor unit, it's still got power going to it, but it doesn't have communication to it. The communication is from this service tool to the outdoor unit It's going to simulate that it has an outdoor unit. Oh, you got to hit OK. Sorry, we missed a step.
Yep. So now it's detecting, reading all the sensors. And there's all your sensor readings.
There you go. We are not hooked up to an indoor unit.
It's giving compressor frequency, expansion valve step.
Just turn the unit on.
Module temperature, outdoor ambient, discharge temperature, external tube temperature, and DC bus voltage.
All right, that's as far as I want to take it. Okay, so I unplugged it right away, guys, because I want you to understand that that's all you need to do is see if the machine will run. If the machine will run, you need to shut it back down because you don't have an indoor coil. So all you're going to do is throw it out on an air code or something anyway. So there's really no point in doing all that. We proved our point. At this point, if I got an E6 air code on this machine, I just proved with that service tool, it has nothing to do with the outdoor unit. So now we're going to simulate the outdoor unit to detect the indoor unit. So all I'm going to do is take the number 2 wire from the service tool and hook it to the 2 wire going inside and not have it hooked to the 2 wire on the outdoor unit. Then we'll power it back up. We should get the screen again. And we can take it the other way around. So Nick, you got a good visual on that? Visual on that? Okay, he's not. Okay, so the first is data monitoring. The second was replacing the outdoor. We're going to go to the third one, which is replace outdoor unit to detect the indoor unit. We're there, so hit OK. And then it's going to make you, it tells you what to do as far as wiring and stuff. Hit OK again.
So now it's giving indoor fan speed, which is set to off. Set temperature, 24.5 degrees Celsius. Indoor ambient temperature, 17 degrees Celsius. And inner tube temp, 18 degrees Celsius, which that would be your indoor coil sensor.
I'm waiting to see if it'll turn the fan on. Let me put it on fan mode.
There it goes. As you see, the indoor fan speed changed to low, and then the run mode is also saying fan.
So I'm not even hooked up to an outdoor unit. This tool is acting as our outdoor unit, and I was able to take the remote and put it in fan mode, turn the fan on. So at that point right there, I've just proven that the indoor and the outdoor units are 100% functional. Now, let's say you're out on the job, and we don't have to zero in on that tool anymore. But let's say you're out on the job, and you've got an E6 air code, okay? On the E6 air code, we simulate the outdoor unit runs. We know the problem's not there. Then we simulate the indoor unit, and we can't detect it. Again, you're starting outside. That's the easiest place for you to start. That way you can test both, outdoor and indoor. But let's say it don't detect the indoor unit. So don't stop there. You're not done yet, because you could have a bad 14-4 wire going in between it. Daniel and I, JD and I, just about every one of our guys in tech support, John Skipper, Richard, almost every one of us have talked about this before. You can take an ohm meter to that 14-4 wire and ohm it out, and you will think there is absolutely nothing wrong with it. You can disconnect the 4 wires outside, disconnect the 4 wires inside, ohm between them, It doesn't show any short between the wires. You think that cable is 100% not a problem. What you got to keep in mind is you're testing that with your meter and the power source of that meter. So whether you've got a regular volt-ohm meter where it's using AA batteries, which has actually got more current capability than this meter does with a little 9-volt battery, but that's my point. You're using batteries. You are not using 230 volt power.
Right. It also matters if your battery is low or not.
That also. So what I'm telling you is that you could have a voltage bleed through the insulation class of that 14-4 wire that is causing your E6 communication error, and you cannot detect it with a normal meter. So that's why, and then something else I want to talk about, why does GREE specify 14-4 stranded
600,
communication wire?
600
volt. Why?
to protect that communication circuit.
But the thing that I always like to tell guys is why we don't let you use solid core wire is, I kind of respond back, how many extension cords have you seen made out of solid core wire? Zero.
Right.
Because extension cords need to be flexible, right? Mm-hmm. You need to be able to unroll them, roll them back up, roll them, unroll, right? Well, stranded wire is more susceptible to that. Same thing with pouring that 14-4 wire. We don't know what kind of bend you're going through and where you're pulling the cable. That 14-4 stranded wire is going to be a lot more susceptible for you to chase that through walls and everything and not kink that wire over and cause a voltage bleed between the wires with stranded as you would with solid core. Solid core is going to be a lot worse. The 300 volt wire versus the 600 volt wire. That means the insulation class is on the wire, individual wires inside there do not have that 600 volt rating, which means you have more of a chance of that voltage bleed between the wires. Again, you may never pick it up with an ohm meter. That's why they specify 600 volt 14-4 wire, because it's flexible and it's got a high voltage rating to the class of the insulation. It still doesn't mean you couldn't get a bad wire. What it means is you're going to have less chances of having a bad wire because of the fact that you used 14-4 600 volt stranded wire. Right? So back to what I was saying here. Start out here. If I can't detect that indoor unit by simulating it with the service tool, I now need to take that service tool inside. You can leave that 2-wire disconnected off the outdoor machine, doesn't matter. You need to leave 1 and 3 hooked up for power. You need to go inside, pull that 2-wire off, hook up your service tool to 1, 2, and 3 indoors. And I'm going to say it because there's going to be one person out there that says, well, you didn't tell me to do that. You need to kill the power while you hook up those 3 wires and then turn the power back on and then use the service tool to simulate the outdoor unit. If it does simulate the outdoor unit and that indoor unit will run, then you know for a fact something is wrong with that wire. And it could be that an electrician pulled the wire or something, ran in a junction box and used wire nuts. We strongly discourage you guys from having any wire nuts on these wires. We've got tons of pictures coming in with water in the wire nuts.
Oh, yeah.
And every other kind of thing you can imagine. So I can't stress enough, a solid cable, 14-4 stranded cable, 1 wire from outdoor to indoor, no interruptions in between it. The only time that it's acceptable to have an interruption there is if the code requires you to have a disconnect inside, meaning it has to have a 3-pole disconnect. Some localities require you have a 3-pole disconnect on the indoor unit. You got no way around that. And if it's required, you're going to have to put it in there. Make sure it's a 3-pole. You got to break 1, 2, and 3 going to the indoor unit. So listen, guys, I'm just going to be frank with you. So many people push back. It's like that is too time consuming. if you really look at it, maybe it's not. Because when you have an undercharge system and you need to charge it up, there's a lot of things we can gain there. If you recover that charge and you weigh the charge out, you know exactly how much refrigerant was in that machine versus what's supposed to be in the machine. So you just answer the question, was it really low on charge? Is that definitely my problem before I start just adding gas into it? Okay? Secondly, do a deep evacuation, triple evacuation. I can't stress that to you guys enough. You need to pull a vacuum, break it with nitrogen, pull a vacuum, break it with nitrogen, pull a vacuum, break it with nitrogen. The more times you do that, the faster you're going to get that thing down to 500 microns. If it's cold outside, you're only exacerbating the problem. It is going to take even longer for you to get that refrigerant out of there and to get a deep evacuation. I've even done it myself, and I've told guys this before, and you'll see it on this machine I got right in front of me. You can peel this jacket back a little bit. If you have a heat gun, you can gently warm that compressor. That will help as well, because you'll be able to any liquid refrigerant that might be in that compressor, you're going to help get that to boil so you get it to come out of there. So a heat gun works great for working on heat pumps in cold weather.
Not a torch.
Not a torch. But I also understand, and I don't want to totally negate the question there. I understand that sometimes it can be really cold outside or really hot outside, and you've got a whole bunch of service calls you need to do, and I need to just see if I can't get some refrigerant out of this machine, get it working so that, and I can come back when my schedule's calmed down a little bit. I can go out there and work on it, or, you know, maybe it's not quite so cold outside. I understand that too. So in those scenarios, be careful. As you know from what we were just telling you, like if you're running in cooling mode in your temperature differentials, like I talked about with that mini split piping diagram, you know that when you put all 4 heads on or 3 heads on, my temperature difference drops to like 10 or 15 degrees. But if I got 1 head running in cooling mode, let's say, and I'm running 22 degree TD, so as I'm adding onto it, I know, okay, this thing's definitely low on refrigerant. So for me to sit here and tell you that myself, I wouldn't add charge into that unit because I don't have time to work on it today, I'd be lying to you. That's exactly what I'd be doing if I didn't have time to fix it that day. I would put charge in it a little bit at a time, go in there, check my splits, start getting that machine to give me 20, 25 degree with all of those indoor units running with the fans on auto. And I'd rather err on the side of caution, maybe leave it a little bit low on charge. Tell the homeowner, look, all right, I'm going to come back. This will get you going for now. We'll be back. I can recover the refrigerant. But when you do that, weigh in everything you're putting in. So you know how much you added on this date, so that when you come back and you recover all that refrigerant out of there, you pull out that part that you just put in there, how much was left? You know, okay, this thing was definitely low. I got a leak somewhere here. I need to figure this out and get it fixed. So, you know, again, the manufacturer's recommendation is going to be pull and weigh the charge, because that's the only way with a variable speed compressor we can assure the charge is correct. But if you use some of what we're telling you here with temperature differentials and stuff like that, can you get away with temporarily adding some charge to the units to get them up and running? Yes, I'm sure you can. Okay?
I would do a few ounces at a time and wait 10 minutes, let it cycle through.
Give it some time. Yep, don't be, again, one thing these machines will teach you is a whole lot of patience. And that's where I say, you may be better off if you're thinking, I'm going to save time by just adding charge. Are you?
Not really.
You might not. So, but I will also say this, guys. I'm not out there working on these machines every day anymore to really give you what I would do. So, That's kind of where I'm at with it. So you got to kind of use your own judgment a little bit, right?
Yep.
So that H7 air code, H5 come up too. I want to talk about that. So I hooked up the thermistor on this thing. I'm going to plug this machine back up. JD, we're going to run this again where they can zero in on this. The only thing I want to make sure you do is keep this back here more.
All right.
Because I took the fan grill off. I don't want to get your hand in there, and I don't want to be putting any pressure down on that.
Got it.
But some things I want to talk to you about troubleshooting these machines and what the service tool will tell you. So my big fat head's going to be getting down there in your way at times too, just so you know. But H5, H7, that's good air code. So desynchronization of the compressor. Daniel's right that a sensor could be the issue. Also H7 could be that we got load conditions or refrigerant flow problems. Refrigerant flow problems will cause that compressor to spin improperly, okay? So before we get into the service tool, I just want to talk about this. So coming off the top here, you can see them here. You've got yellow, blue, and red going to my compressor, and I got to get this off of fan mode and actually put it on a mode. So we'll put it on heat mode. Not familiar with this remote. All right. But I can't get, I don't think I can get it. Well, maybe I can. They don't give me much room here. There we go. All right. So I got the amp probe hooked up. This machine should be coming on in a minute. So these compressors in these machines, this is a 230 volt unit. It uses, and I've talked about it before, there's video out there about how an inverter driver works that we've done before. And it shows you how the IGBTs, the insulated gate bipolar transistors, switches basically create its own three-phase sine wave to run this three-phase compressor. That is a three-phase AC compressor. We are taking single-phase voltage, creating a DC bus. The DC bus is boosted up with the capacitors to give us the high DC bus. And with that, then it goes through the IGBTs, creates its own three-phase sine wave off the single-phase power to drive this three-phase compressor. So desynchronization, what does that mean? That means the compressor's spinning out of step. It's not in phase. You could have the same thing with a compressor where it won't start because it's single phasing. That's a big term that's always talked about in commercial three-phase compressors, okay? If you only got single-phase power going to a three-phase compressor, that compressor is not going to run because it is quote-unquote single-phasing, okay? Same thing here. If the machine runs for a while, you could, and then all of a sudden gives you an H5 or an H7, it could be caused because of refrigerant flow. Because you got to remember, again, the service tool, it gives you condensing coil temperature, it gives you your evaporator coil temperature, and you can convert that to pressures. But we don't have a high and low side gauge. But if you've got a flow problem and we can't push that pressure off our high side in through our metering device and feed that evaporator, okay? So you got a restriction, right? Maybe the EV is not open right. I don't know. What that happens, and let's say not full restriction, but a good partial restriction, if that's happening, that compressor's trying to work up against that. You got a three-phase motor in there trying to spin up against this ungodly pressure that it's not liking. So it could actually go out on a phase problem or desynchronization because we can't get the refrigerant to flow.
Right.
Not because there's anything wrong with the compressor. So, like Daniel said, we need to ohm out the thermistors. If that's not it, the other thing we can do, and as you can well see, and I've got the amp probe on it right now, I can measure the amp draw of this compressor. And if I watch that thing, and all of a sudden that amp draw keeps going up and up and up, and all of a sudden it goes out on that H7 air code, I'm pushing up against a block. The refrigerant's not flowing. That's what's causing my H5 or my H7. It's not the fault of the compressor itself. Makes sense there? See where I'm going with that one?
Yep.
It could very well be a refrigerant flow problem causing an H5 or an H7 air code. Now, it could actually be a mechanically failed compressor too. If you hear that compressor going in there grinding and carrying on, and I've heard them over the phone, can you listen to this thing? Okay, man, you got a bad compressor. I'm not arguing the point. You win. But this compressor is running right now. It's pulling 4 amps. I can't even hear it. I can barely feel the vibration of that compressor putting my hand on this jacket. So, and then this is just a little bitty, what is it, a 9K? My eyeballs are so bad anymore I can't see. But anyway, you get my point here. So don't be so quick to judge a compressor bad, because you could end up changing that compressor or changing that outdoor unit, and you could have something stopping up your refrigerant flow. Maybe we didn't open the service valve. Trust me. We've had those phone calls,
Oh, yeah.
haven't we?
All the time.
When we've got a picture and you're like, the valves ain't open. And
They only open one.
Yeah. So, I guess we could simulate that.
Or
Close
they
the
don't
valve
open
a
it
little
all the
bit,
way.
see what it does.
They just crack it, and then they don't continue.
So I
to
wanted
open
you guys to see, you can absolutely measure the amp draw with an AC amp probe on this compressor. I actually just did all 3 wires. All right, so now let's focus back on the service tool. If you want to hold that up. Was there more questions?
There was.
Let's do that first. Let's do questions, then we'll come back to this.
All right, so next question. What makes a single zone go into FO? He says he has one installed 3 hours away. As soon as they turned it on to heat, it went to FO. And they put gauges on, it matches the PT chart. What is next?
Could be an indoor ambient or
indoor
coil
coil
temperature sensor failure.
Yep.
We know it's the coil, but I tell them to check both. It's
Yep.
the same plug. And the other thing is, if you need one, you're getting both. Right?
Yep.
So, but again, use that ohm chart. You should be able to easily test that. But if them thermistors check out, you might need to start that unit up, because here's the other thing. Remember what I said. Remember the piping diagram. I think you can get an FO if you've got a restriction.
Right.
Because if you follow that single zone piping diagram, your metering device is in the outdoor unit. If we're not feeding that refrigerant through, and we're not getting that refrigerant back, and that compressor's going, hey, what's going on here? It thinks it's out of gas.
Right. And the other thing is, too, the FO code is a hard reset code. So
Yep.
you got to do a 10-minute hard reset, power it back on, and if it goes into FO right away, then I'd be looking at sensors. If it starts up, then we'd be looking at restriction.
But we stress that all the time, and I'm glad he's paying attention. I guess he's looked at our air code tool. That's one of the first things we tell him to do, is hook up the gauges and see if it is equivalent to your outdoor temperature, because it should be. If it hasn't been running for quite a while, then you'll know, that could be a dead giveaway. If your pressure is supposed to be 150 pounds, you hook gauges up on both sides and you got 25 PSI, more than likely that thing is out of gas or near out of gas, right?
Right.
So.
All right, next question, good question. Will this tool only work on GREE, or will it work on other products and brands?
It only work on GREE.
Welcome back, everyone. There's a plethora of information there, and I always love talking to Greg and JD, because that goes for our whole technical support team. They always have answers and great explanations to help me solve exactly what's going on. So definitely a huge shout out to them. I did want to mention on our As far as our error codes go, there is a tool on our website, greecomfort.com, as we can see here on the screen. Uh, so the way that it pretty much works, so you pull up the troubleshooting error code screen, and if you want to go ahead and type in, I don't know, E6, and just to get a good example as to what the tool is capable of. So as we can see here, it's troubleshooting steps, notes, pretty much things to look out for to check. That way, you're not, if you do call in our technical support line, sometimes the queue does get a little bit backed up. Um, and that way you're not having to wait on site for us to call you back.
Yep. So just to add to that, Jesus, when you do call in, typically it'll send you an automatic text. It's going to be a link to get to our website and to the error code troubleshooting tool. So while the contractor's waiting, they can punch in the error code and kind of just dive into the steps. And sometimes by the time you call them, they'd be like, "Oh, we already used your error code tool and we figured out the issue. Thanks for calling." And they're already on the road, because this is basically the script that we go by when we call the contractor. So we have that at their fingertips.
Perfect. Yeah, JD, if you want to mention the technical support number for everyone, the audience that's listening.
Is I
So we
don't know how
got
to
it.
call it. I forgot it. I have to look it up really quick.
That's okay. So we got 888-850-7928.
That's it. That's it.
Anytime you have any technical support things that you're wondering or that you're stuck on, just go ahead and call us in, and we'll do our best to promptly handle those calls. But it looks like we have a couple questions that came in while the broadcast was going. So they're asking, where can I get these tools? Uh, JD, if you want to mention
Yep.
where we can get those tools.
Yeah, good question. So you just get with your local distributor, and they'll give you pricing and availability, and they can order those up if they don't have them. If you don't have a distributor or don't know where it is, you can go to greecomfort.com, the contractor drop down, and then go to find a GREE distributor, punch in your area code, and it'll bring up all the distributors in your area.
Perfect. And so as we can see here on the screen, so let's find distributor screen, and you pretty much just punch in your zip code there, and it'll populate, exactly who's in your area for the service tools that we were mentioning.
I said area code, I meant zip code. My mistake.
That's okay. Nick, if you want to pull up the service tool nomenclature there, that way we can have that for the audience. Let's see. Yeah, there it is. So again, here's our the service tools that were featured in the video. So we got the single zone, the multi-zone, and if you're working on multi-pro, there it is for you as well. And as the video had mentioned, the amount of data that's that service tool actually provides is it's critical. It's crucial for the technician to understand exactly what's going on and see exactly why the unit's either down or not performing the way it should. And so we had another great question come in as well, regarding the service tool they were asking. So does the service tool save error codes?
Good question. No, it does not. Say some of the error codes, will automatically reset. A lot of them say, like, if it's your condenser fan motor, you get an L3 code. That code will, after so many failures, after so many attempts, it will lock the unit out. So, when it locks out, it's going to store that code until power is reset. So typically until the contractor shows up. So, the unit will store the code at least, or display the code until power is reset. Some of the codes, do not lock the unit out. So it kind of depends on the code. Even FO, it will lock the unit out, because typically it's freezing up. That's just to protect, of course, the indoor fan motor, just, protect it from, the ice building up and causing other issues too.
Yep. So I did want to mention, as we can see on the screen, the Flex R32, there is a service tool, that we don't have it yet, but it is definitely on the way. And I don't know about you, JD, but man, I'm pretty excited about that. I was actually just doing a training down in Miami and messing with the R32 Flex, man. It's pretty cool what it can do, the
Well,
capabilities of it.
It's an awesome unit, that's for sure. So yeah, it'd be really nice to get just something to plug in and, check everything real fast again, just like we have for the multi and the single zone. I say it just saved a lot of time, a lot of, aggravation trying to get in there and unplug and ohm out. And, especially a lot of the sensors you got to, you know, harder to get to. You got to have micro leads to ohm them out. A lot of contractors don't have micro leads, so they're
Right.
trying to rig up wires. This will just, you hook it up and tells you all the ohm values.
Yep, that is true. So I did want to mention another resource that we have for contractors out there. It is the contractor app. So if you want to pull that up on the screen here, go to, I believe it's greepros.com. And this is just another tool to help you out, when you're out in the field, troubleshooting these units, pull up videos and explanations to several different error codes that you can experience. And so, that way, if you are waiting for us to call you back, you can go through the app and, you may be able to actually correct your issue, as JD has stated. Going through the website is one way, and going through the contractor app here is another way, and it is via phone friendly. So, just for reference.
Yeah, and Todd, just to elaborate on your question, the unit itself does not store the code, but it will display the code if it's a hard lockout code until power is reset.
Right. Awesome. Well,
Any more questions, Jesus?
yeah, that's what I was looking. Looks like no. Let me reload it one more time. Looks like I believe that is it on the questions. Uh, again, if you guys, have any, yeah, again, if you guys have any more questions, just go ahead and make sure to click that question mark icon, and we'll go ahead and try to answer that for you. Any relevant questions, and so. No, I think that's it. So I think that's pretty much going to wrap us up here. Again, we want to thank you guys for participating on today's broadcast. If you'd like to go back and revisit any of the training today, we'll have it posted on the YouTube channel at GREE Comfort, and you'll also be able to find it on our website. So I did want to mention, make sure you guys tune in to our June 4th Talking Comfort Live. It's the first Wednesday of every month, so it's an easy thing to remember. What we'll be covering was what's new with R32 Flex and what can it do. We'll also be explaining the misconceptions on high walls and mini splits with the misnomer. We'll also be avoiding heat hazards in the attic. So another mini split advantage. Again, we want to thank you guys for uh, joining in on the broadcast. And if that's it, I guess we'll check out. Just remember, at GREE, we're by your
We're
side.
by your side.